Hello everybody, how's it going? My name is Jack Toll, and today I wanted to show you a bit of a demonstration of the arXivRag project that I've been working on. But before jumping straight into the demonstration, I first wanted to quickly go over sort of what the data looks like in the backend for this project. So my data is being hosted in a Pinecone vector database, and I have two indexes for the project. I have the arXiv metadata vector store and the arXiv project chunks vector store. So let's have a look at the arXiv metadata vector store first to get a bit of an idea of the data that it holds. So the first thing that we notice is the vector count on the right hand side. So you can see that this vector store, this index, contains over 1.9 million vectors. So each vector in this index corresponds to a research paper. So if we scroll down a little bit, we can see the text of that's contained in each of these vectors. So this is going to be the title of a research paper that is also combined with the authors of that research paper here. So this is what's going to be sort of displayed to the user after they input the paper that they intend to learn about, and then this is kind of what's going to get retrieved and then displayed to the user. You may also notice here that we have two bits of metadata for each of the texts. We have the date created and the document ID. But in this version, the new version, we don't actually include the date created anymore in the metadata pre-processing and uploading stages. This is because I kind of decided that it wasn't useful or required for the functionality of the project, and it was just taking up a bit extra data, which corresponds to a bit more money being spent. And when we're talking about millions of vectors, it can kind of add up over time. So it's best not to include information which we don't crucially need for the project. So in the future implementation, going forward, we're only going to be using the document ID for the only piece of metadata for each title author pair in the vector text. Having a look at the arXiv project chunks database, we can see that this contains considerably less vectors. Now, this is because of the implementation that we've tried to go for here. So we only want to download papers and store the chunks for papers which users have actually asked for and have requested in a sense, meaning that by default, we stored no chunks for any research papers. And then as users use the system, they're going to be downloading papers, and then it's going to get sort of permanently saved. So that means every paper only needs to be downloaded once before it can be very, very quickly retrieved. But that also means that we're not storing papers unnecessarily that nobody's using either. And the majority of the users of the system are only really going to be focusing on a small minority of the papers, probably machine learning AI related papers, but it could be any papers from arXiv. So having a look at what these chunks actually look like in the database, we can see that in the text, we just have a chunk of text, which comes from different papers. But each text also has its corresponding document ID, which is the document ID from where the text was originally where the text originally came from, where the chunk came from. Now that's really, really important to note because there is a potential here for sort of bleed. So if you think about it, when a user inputs a query, for example, tell me about this paper, it's going to be a broad query. And the thing is, if we don't specify a filter of a document ID, it's just going to be searching that query with respect to all the chunks in this database, which may be tens of thousands of chunks, right? So we actually can't be certain that the LLM is going to be retrieving the chunks for the correct paper unless we filter out for it. So that's why we make sure that each chunk also has a document ID showing sort of where it originally came from. So that means that at runtime, we can filter out for the document ID that the user selected for to make sure that we're only getting chunks of information from the paper that the user sort of intends to learn more about. So you can see a few examples here. If I just hover over them, we can see some chunks are going to be smaller, some are going to be bigger, some are going to be tiny. This one's bigger, for example. Now, the reason for this variation is because I'm using the semantic chunker that is integrated with LangChain. In the future, I may use a more predictable sort of recursive character split or something like that to make sure that chunks are a bit more uniform in size. But I found that the semantic chunker actually works pretty well at maintaining sort of the semantic sort of meaning of different chunks of text across a document, especially when we're talking about only filtering for a given document. It seems to work pretty well in practice. So now that you've seen sort of what the data that the system is working with looks like, let's do a sort of practical live attempt at this. So I picked a random paper, in this case an invitation to deep reinforcement learning. So because of the way that this project works, users of the project or the application should already have in mind the paper which they wish to learn more about, essentially. It's not to say that the project can't be used. It's not to say that the application can't be used to find research papers. If I just typed in reinforcement learning, papers that have the title, or have the text reinforcement learning in it would come up. But I wanted to, because of the similarity search implementation, it's a good idea to have in mind a paper that you're sort of struggling with that you want to learn a bit more about. So I'm just going to copy the title for the paper here, and I'm going to go here. So let's just have a look at a few of the imports and a few of the global variables, and then we'll go straight to the demonstration. So we import OS and we import arXiv. Now this arXiv import is really important. So this is actually a library which is a wrapper around the arXiv API. Now what this allows for is easy downloading of research papers based only on the document ID. And as soon as I saw that, I was like, oh my God, that's amazing, because that is the exact functionality that I needed. Because remember, this document ID, I already have. The user selects it, it's part of the metadata, it's part of the chunks. So as soon as I realized that we could use that exact same document ID and sort of dynamically pass it into this this template here, it was like perfect. Now we have a mechanism of remotely on the spot downloading PDFs for research papers. The rest of the imports are just LangChain imports, right? So LangChain has a bunch of community integrations with Hugging Face embeddings and document loaders and some experimental ones. So that's where we got the semantic chunker from. They've also got their own Pinecone integration and a few sort of prompts and output passes. And sort of a really important and cool one is the OpenAI implementation as well. So for this project, I'm using the a GPT 3.5 Turbo inference model because it's cheap, fast, and seems pretty reliable, especially because we're providing the content. Now, a few of these global sort of variables, we have an embedding model, which we just set to an object for the Hugging Face embeddings embedding model. And that's really important. We actually use that in a few places. We pass that into a vector store because anytime we want to sort of call on this vector store, right? Whether we're uploading text to it, whether we're retrieving stuff from a vector store, or even in our semantic chunker, we want to use this embedding model because we're working within the vector space. I did originally use the OpenAI embedding model, but that got very expensive very quickly, and I figured, well, LangChain offers a Hugging Face embeddings integration, and I have a GPU that can do it, and it can do it quickly, so I'm just going to use that. Here we just sort of have our metadata vector store and our chunks vector store that we sort of already sort of predefine from the existing index, passing in the embedding model and also the index name. And we do that for the chunks vector store as well. And here we just create the semantic chunker object, which we use when chunking a document. Now, scrolling down in this cell, we have all of the helper functions that actually make this application kind of work, right? But I've covered these in the blog post that you'll find this video in, hopefully. So I'm not going to cover them here, but they are covered in detail in the post. So if you're seeing this on YouTube, for example, just check out the blog post and you can read a little bit about sort of the purpose of these functions and sort of how they work. Now, let's just get started with the demonstration. So let's just run this cell. Now, the first thing that we realize at the top there is that it says enter the title or topic of the paper that we're interested in learning more about. Now, since I already have the title for the reinforcement learning paper copied, I'm just going to paste it in here and press enter. Now, you'll see that the first result that we get is an invitation to deep reinforcement learning paper by the authors. So we can see that the similarity search worked there. So as soon as we put in the title for the paper, it converted that into passed that through to the embedding model, and then it did a similarity search in that whole metadata vector store. And then these are the top 5 papers that we are most likely referring to. And since we copied and pasted the name of the research paper in, we can see that it's the number 1 result. So because of that, I'm going to hit number 1 and click enter. Now you'll see what it does first is it does a check in the chunks vector store to see if chunks for that paper exist already. You can see it did the check and then it realized, oh no, chunks don't exist for this paper yet, so let's download it. So it downloads the paper here, and now it's going through the steps of loading the paper, and then passing each of the pages through to the semantic chunker, and then embedding each of those chunks, and then uploading the chunks. Perfect. So now that it's all uploaded, it's asking us to please enter our question. So for demonstration purposes, I'm just going to ask, explain a methodology explored in the paper, just as a standard baseline question, just to make sure that it's retrieving the chunks for this particular paper and not some other paper, to make sure that the filtering is working, etc. So if I do this, I hit enter, it again will do a similarity search with respect to all of the chunks in the, well, not all of the chunks, just the chunks for this particular paper in the chunks vector store. Here we see the response from the AI. So the paper explores a semi-gradient method, which is a type of reinforcement learning method used to estimate the optimal action value function in a Markov decision process. So here you go. It works. We can ask a broad question, something like tell me about a methodology, and then we actually get the response from the LLM, a nicely formulated response, which sort of explains a methodology. Now, in the deployment, we're going to make it so it maintains memory across questions, so we continue doing a back and forth. We'll also make it so we can ask a new question and it'll do another retrieval on that question. So you can almost imagine that, let's say I read this response and then I was still confused about something and I wanted to ask a follow-up question. It wouldn't make sense to pass that question through to another similarity search, right? Because we would just get the same information again, essentially. It makes sense that we can continue having this conversation chain, asking follow-up question, until we're satisfied. And then we can say, ask a new question about the same paper, which the next question that's entered will do another similarity search. Or we can go back and ask a new question about a new paper, etc. So in the deployment, we're going to make sure that we sort of have these different functionalities covered. But in this simple prototype demonstration, we're just showing that it works, that the RAG pipeline that we've sort of created a bit from the ground up, covered in part 1 of this blog post series, actually works. So I look forward to seeing you guys again soon, and take care.